intelligence algorithms. Okay, this is the lineup of my presentation. Okay, the main problem that we have when we started developing this didn't appear, which is an interesting story. Didn't appear because we remember one day that we are going to implement this thing. Okay, it came the other way around. So we have a problem, which was to put energy communities to work, get data from the houses, okay, process that data and take decisions over if the batteries of the cars are going to be charged, if the batteries of the houses are going to be charged or discharged. So if we are going to charge the cars during the night or immediately when they arrive. So we have to take all sorts of decisions about houses to optimize the energy consumption. Then we started using this system. Basically, they were based on IoT platforms from one of our partners, which was CleanBots, and we found lots of problems. Okay, so we have data from multiple sources. Okay, some are TCP, others is XML, some don't have any kind of protocol inherent to them, so they are very specific. Okay, they come in different data rates. Some are, for instance, the consumption of a house, and they came every minute, and other data comes only every 15 minutes. That means that what we are doing exactly with this data, we are collecting this data, feeding it to an AI platform for taking some decisions on what to do with the actionable loads. Okay, and then we have to accumulate data. Others, we only have one sample during the period that we are going to do this thing. So there were lots of problems that we were looking at. Also, we found that there were lots of missing data. Something as simple as some kind of device that disconnects from your Wi-Fi network for some period of time, and then you have missing data. Okay. Also, another thing, since we are using AI, everyone knows that AI sometimes gives incorrect decisions. So we have to be sure that the decisions performed by the AI are correct. And if they are not correct, they are corrected somehow. Okay, at least that we do not pass the limits of certain devices. Additionally, we want this to be light, so capable to running on a edge or a simple Raspberry Pi platform, or even simpler than that, and be flexible to be run in multiple levels, okay, from edge to the cloud, wherever that is possible. Along the time, so basically we had to develop something like a data processing system. Along the way, we have many platforms for this, from MapReduce, Hadoop. Later we have Apache Spark, Storm, and Flink. Okay, and nowadays we have some other platforms which are not so developed like that. So we wanted to have a simple platform. So what we have been using is a real-time processing platform that processes data when it arrives, gives us analytics, and at the same time also gives some actions. Okay, the goal is not only analytics but also on actuating on devices. So what we need low latency. We need to have reduced bandwidth. So that's why we are transitioning to the edge. Okay. Also improved privacy. For instance, in those applications I was talking of home automation, surely don't want your data about your habits on your house to go to a cloud somewhere, okay, that they might know a lot of things about you, okay. And also we want system autonomy, that we can do whatever we needed, okay, with these things. So there are some limitations. Existing systems like Apache Storm, Apache Spark are basically designed for the cloud, okay, where you have lots of resources. Some of them are not very compatible at TH. They are very heavy to be run at TH because of their resource consumption. Okay, and there is also a lack of a standardized solution for the edge. Okay, there are some attempts, but there's no real solution. And additionally, okay, what happened to us is that as we were detecting some of the problems that I was discussing before, we started developing, and then we looked at the system and saw, okay, we have something that is different from what appears in the market, what are the current state of the art. Okay. Solutions that appear are also generic. Okay. There is a gap also in data preparation. Okay. Things like frequency harmonization, handling of missing values. You have to do it by hand. You have to engineer all of these things. AI decision is also something that is not present in this system that we know. Okay, so that's something that we have to validate. What is the consequence of this action? Are we using too much energy, for instance? Are we going above the levels of certain devices, for instance, the batteries or the cars? So Percepta basically is edge stream processing system, okay, that handles missing data, different data types, different frequencies, normalizes data to machine learning or artificial or whatever it is, artificial intelligence algorithms, okay, and then validates the AI decision. And it can do much more things. Okay? Yeah, it just depends on what we implement as models for Percepta. Okay, so basically it goes to different sources, MQTT, RabbitMQ, HTTP, builds a standardized message, which is basically on a format that is usable by in this case, in the present case, a machine learning model. Okay, these decisions are a reply to Percepta, which validates these decisions internally and sends them to the environment, and we are sure that we are not going to do nothing wrong with the system themselves. Okay, so Percepta is capable of supporting multiple protocols and formats. Okay, to that purpose, as we can see, it can use tools that have been developed by Arrowhead fPVN. Okay, it also is able to have models which are defined by the user or already provided by the standard installation for missing data, duplicate, misplaced data, irregular data, things like data which is not correct. Those things can be corrected by Percepta and the models that we put there, and something else that we didn't think about. Probably it is possible to use. Okay, so it basically is able to you can put whatever you need in this data in a standard way. Okay, validate also the decisions. Okay, store all logs for the system and all data that passes on the system. This is very interesting, for instance, to understand if these validation modules are really working, okay, if our artificial intelligence algorithm is failing somehow, okay. So we can have logs of all of these things. So these are basically the internal mechanism. Okay? And then we can use these logs to make alerts to the user and tell them, okay, that something is wrong, something went wrong with some of the modules and so on. Okay, it depends on what you need. You can add the models that we need. I will not go into lots of details here, but basically the numbers indicate the sequence of events that occur in our system, since, for instance, the data comes from the EV charger, all right, from energy consumption in house in the PV panel somewhere. So this is completely different data formats. They basically are adapted here, okay, using some kind of a translator. They go to the system manager that takes care of out of order, handler, missing data, harmonizes frequencies, and so on. Okay, and they all communicated through a bus. In this case, we are using RabbitMQ for communications. Okay? If it detects, for instance, missing data, it can use predictions of the data and correct this data with those predictions. Okay, these models can do this kind of things. Goes to the machine learning model, okay, and runs also the safety checks on the system. So these are basically the models that we have. Okay, I think this is the part that encodes the predictor that encodes the data into the model that is specific to the AI. Okay, that safety model that takes care of validating decisions by the machine learning model. This is the forwarder, which I didn't talk till now, but basically is another adapter that transforms from the internal format that is used in Percepta, okay, to the external format that is used by the EV chargers, for instance. Okay, so some characteristics. Basically, it has some horizontal scalability. Okay, so you can run all of these models in a single machine, but these models can also be distributed across multiple machines, communicating through communication middleware bus like RabbitMQ, okay, which is presently what we are using. Okay, it is also lightweight so that it can run on edge devices. Okay, it can support multi-environment setup using different operating systems, using things like Dockers. Okay, so all of these models can be put into Docker files and run wherever we need them. Okay, for the moment they are mostly running in a single computer, which for the moment it's also enough, and it was also our objective here. Okay, so where does Arrowhead fit into this all? So basically, it can take care of dynamic service orchestration. Okay, takes care of some security for the system, authorization, authentication. Okay, it can even, for instance, validate all the exchanges, particularly with actuations. Okay, so we have to be very careful when we are actuating over some electrical device that we are not running into some kind of a problem with the device because someone else is making as if they are the authorized person to run the system. Okay, and also on systems to systems of systems interoperability, translating all of this data. Okay, so we can use, as you can see here, the translator to translate data from the EV chargers and to the EV chargers also. Okay, we are also using another model that we have done at the start of the Arrowhead fPVN project, which was called Edge for CPS, that can enable the placement of Docker-based models in using different operating systems in a distributed system. On all of this, and I'm simplifying a lot here, can be managed, all of these models, by the Arrowhead frameworks, so that you can find where to put all of these things in the system. Okay. Well, this is only some ideas of how it makes the registration using the Edge for CPS, Docker Engine, Service Registry, and all other Percepta models containers. I will not go into details here. Okay, most of these things are self-explanatory. Okay. So what we are doing right now, we are putting this to run. No, we are not putting. It is running now in real installations. Okay, managing houses and the chargers, car chargers, EV chargers from iCharging. Okay, a Portuguese company. It has been running for some weeks without too many problems. We had initially some minor issues, but those minor issues were not related with the software, were basically the physical rules, which were not what we expected. Okay, so we are going to scale this, adding more adapters, more handlers for different kinds of problems, also running performance tests, varying load condition, measuring CPU usage, memory, disk utilization, and so on. So more or less, this is what are the following steps in this system. Okay, I think that's all from me. Thank you very much for your attention.
Thank you very much. Just let me stop the recording before the questions.